Well, hello there. My name is Chris Fernandez. I'm a solutions engineer with Keysight Technologies. Today I'll be demonstrating our implementation of 10-base T1S using IxNetwork. As you already know, Keysight already supports many type of industrial and automotive interfaces from all the way from 100 meg um, base T1 all the way to 10 gig base T1. And our new interface that we're going to be showing off today is going to be the 10 base T1S half duplex. Um, for that, I'm just going to take a quick look at what 10 base T1 is. 10 base T1 is actually a bus. It comes from our bus architecture, sharing a cable where multiple nodes um, use the same media to communicate. You usually have one node here on the end that is the coordinator. That's usually node 0 becomes the coordinator by default in our tools, and that gives the what we call a beacon on the wire, which is the indication for other nodes on the network for the opportunity to transmit. So for that, I'm gonna go back to I'm gonna start my my IX network here. So on the right side here, you can see we have a Novus one fully populated with all our supported interfaces from 100 meg all the way to 10 gig. And on the very left side here, the first three ports here, 1, 2, and 3, are the ones that we're using for this demo. So as you can see here, this on the right side here, on the bottom here is the port number 1. As you can see, it's a 10 meg. It's half duplex. And for the what I was talking about, the physical layer collision avoidance protocol information is over here. That's how you know that the protocol is active, since this is not Ethernet layer packet. So on IX network, the way we implement this, we first you have to go into the layer 1 properties for the port after you bring in the ports into your session. Under general here, we first you choose the speed for half duplex and the media for SDMI. And after that, you go into the PLAC A configuration for nodes 1, port number 1 here. I made that node 0 being the coordinator. For port number 2, I made that node number 2. And for port number 3, I made that node number 3. And I just click OK. At this point, everything going to get reset, and the port's going to restart communicating in the bus. For the scenario here, I have a simple configuration where I have a MACsec on all 3 nodes, and I also have GPTP on node 0 and node 2. As you can see here, the grandmaster clock is on node 0, and I have a slave clock on node 2. For information about the PTP and uh, the uh, the the control plane traffic for that, you can go down here and you can look at the number of sessions active, um, uh, messages, announced messages, sync messages sent and received, and follow-up messages, and etc. So as you can see here, the information is going across the bus correctly. And for information on the offset and the path delay, you can go down here for more information. But for now, let's focus on the MACsec portion of this. So for the starter here, I created 3 nodes, um, and each one of them has MAC addresses, right? So there's 2 nodes in here on node 0, so that's 011 and 012. On node 1 is 221, and node 2 here is MAC address 31. For the MKA, so we'll use the MKA as for key server negotiation, and as expected, the lower MAC address here is going to become our key server. And now that the scenario is up and running, we can just simply start sending traffic. So this traffic here, I'm gonna be sending over to from I'm gonna be sending this traffic from port one all the way to port two. Um, it's just a simple IPv4 traffic. So I'm gonna be sending 500 packets, and it's gonna stop right after that. And what we're gonna be able to observe is that the traffic that are seen on the traffic will be seen on both ports. For that, I'm gonna actually capture the packet on both ends. So for that, I was just gonna close the earlier capture so we don't get confused, and I'm gonna start the capture here, and then we can send traffic. Okay, so I'm gonna start capture now, and now I'm gonna be able to send traffic. So traffic is again, I'm sending 500 IPv4 traffic from port 1 to port 2. So the traffic should run for about 5 seconds or so, and it's going to stop, and that's when we're going to stop the capture, and we can take a look at the packets that got transmitted. So let's take a look at first port number 2. What we're going to be able to observe is that the same capture was going to be able to see it on both ports. So let me see if I can open both ends. So this is from node 3. So I'm going to open from node 2 as well. I'm going to open them side by side so we can compare. And let's take a look at the last packet for IPv4. So one thing that we can do for sure is look at the conversations. So let's just take a look at conversations for IPv4. So we can see packets were sent, both ends, they're the same. And let's take a look at the packets that got transmitted here. As you can see here, it's the same packet, the 861.517, 861.517. And we can open it up to see if this is exactly the same packet that we're looking at. 6B ends with A2, 6B ends with A2, and that's correct. And if we send it out and look at the encrypted packet, we can see on both ends they are both the same. So anyway, this is a quick demo just to show how to send packets in an encrypted manner on top of our new physical interface 10-base T1S. I hope you enjoyed the video. If you have any feedback and questions, please feel free to reach out to us. And thank you very much. Bye.